Beg your pardon?
If it do it like.
Yeah, great to go less.
Okay.
You know, yeah, you want to do a good job, but as long as if you go less, I'll be all smiles. We need to go to.
Good afternoon, everyone. My name is Jonathan. Today I'm going to make a presentation for my final project, directory synchronization using Go. So what's my objective? What is project all about? So basically, I'm building a project providing same functionality like a Dropbox. So the users in a same group, they can do some updates to the shared folder. They can delete something, they can update something, and they can access the files from the server. And so my purpose is to do a pretty similar project which can update the files in the target directory using the files in my source directory. Before going to the code, I'd like to talk about my design first. So basically, my design right now, it is a client-server model. And I have a client, I have a server. It should be spawned by a different process. And both client-server have a send file and receive file function, which will support the file transfer between the client and server. And for example, suppose there's a file transfer happened from client to server. That means the server want to do an update for that file. And if I do a file transfer from server to client, that means the user want to download some current file from server. That's basically the activity flow of the system. And I have some other, I defined some help packages like directory synchronization. The reason why I want to put directory synchronization is I want to do a directory synchronization before I move to a file synchronization. So, for example, like I have some files to update, to create, to put in server, but I don't have the same folder. So I want to make sure the folder structure in my client and server are same. So after that, I can move my file to that folder to put my file in the correct position.
Very dangerous to synchronize the directory tree.
Already.
Suppose somebody accidentally types in C:, you just trash their machine.
Oh, so my idea.
My model is one directory at a time. You know, feel free to argue with me. You need some sort of safeguard to prevent people from trashing the machine.
Yeah, my idea right now is I want to do a check first. I want to check the directory structure, it is same or not. So if it's not same, I want to create some folder to make sure it is same. So after that, I can do a file transfer to synchronize my files. That's what I think about right now.
Might give them an option to set the limit of how deep you'll go.
Oh, okay.
Something.
Yeah.
It's so easy to make a mistake. Just type in the wrong thing.
Okay, yeah, makes sense.
This is taking half an hour. It's trashing my machine.
And second package named file check. So why I put this package is I want to do a file check first before I do a file updating. For example, like if the new version of my file is same with the old version, so I don't need to replace that. I just leave it. I just keep the old version. I don't need to do any change with that. And the server and file system, that basically will provide some help functions for client and server, like get file list. For example, like the user want to get all the file names in some folder and provide some help functions like that. And my implementation idea is like first thing I use Go. I use Go to implement all my project. And the reason why I'm using Go is Go provides some concurrency feature using Goroutines and channels. And Go basically it is a programming language developed by Google engineers. It is a static typed language which supports Goroutines and channels, which is very convenient to communicate between different Goroutines using channel. And I plan to use NAT package for the communication between different client server, and use IO package to do a file transfer, use pass package to do the directory synchronization. So I will go to the details of those stuff in my following slides. So let's talk about the basic Go syntax. So it is a little bit different with the programming language we familiar with, like C++ or Java. So for example, like if you want to use some package, you have to import it here. So in this case, I import a format package, and I can use format package to print out something to console. And this is the function here, and here I'm creating some variables. And you can see the syntax here is pretty different with some language we are familiar with, like semicolon equals 1. So we don't need to specify the type of this variable, and it will be automatically defined when I do this assignment. And something if statements. So this demo just give us a basic idea about how to use Go. So let's talk about the concurrency feature of Go. So basically, concurrency feature in Go happens between different processes, and we use different Goroutines. And the Goroutine, it is not a process, but it can run at the same time. Suppose I create a bunch of different Goroutines, and those stuff can run at the same time. So I did something to demonstrate the Goroutine. And so basically, Goroutine, it is a left V thread supported by Go runtime. And a Goroutine, it is a function that is capable of running concurrently with other functions. So in my demo here, I create a function, and the syntax to call the Goroutine is like the len 18. I use Go keyword and just invoke that function. So here I'm launching a new Goroutine. So and I will run this function, and after that come to my main function. So you can see in my output here, those things, the Goroutine function and my main function are run at the same time. So that's why I print hello there first, and then I print something Go origin to be printed in my help function. So channels. So channels basically used with Goroutine together, and channels, it basically what a channel does, it is shared data. So people can put some data into that, and another Goroutine can extract some data from that channel. So it is a pretty convenient tool for us to communicate between different Goroutines. So the syntax here is I use left row. Here I can push something into that channel. For example, in here, the type of that channel is a ball. So I push a true into that channel, and in the main function, I can get that true value out in the len 27. So I call this Goroutine first, and I can get something from that channel out into my main function. So there are two different functions running at the same time, main function and my hello function. I can transfer my data using the channel between hello function and main function. And
does line 27 evaluate to true?
It will basically pop this one out.
You put true in the channel, so line 27 should pull true out of the channel.
Yeah,
right?
it will. So after this line, the channel is empty. Yes. I didn't print out the true, just pop that out. Yeah.
But if you had, you would have printed true.
Yeah, I can do that.
Whatever you put in the channel.
Yeah, sure. And another thing I like to mention is it is a blocking operation. Like for example, in this statement, if I doesn't have anything in that channel, it won't pop out anything, and the program will stop here, and won't execute the following statement. So that's one feature of the.
Well, because at line 26 you have a Goroutine, so that's running concurrently. So line 27 will hang, but the Goroutine will continue on.
Oh yeah.
Right?
Yeah.
Is that correct?
Yeah. And here I did a mock Dropbox. So what I did for this demo is I'm trying to synchronize something into my result set. Here I didn't do a file, I just use a result. And my results, it is a bunch of string. So I just append something into my result set and print it out. So basically, what I'm doing here is I create a result and call the dropbox function, and I use different function to append something to that result. And you can see my result here. I just append some different result from different function to that result set. So let's come to the net package. So I plan to use net package in my project for the communication part between the client and server. So basically, net package in Go provides a portable interface for network input and output. And so how to use the net package? You can use some interface provided by net package like tell, listen, and accept to establish the connection between client and server. And so in the client part, I'm going to create a code, and in the server part, I'm going to create a listener. So you can see the code here. This function, another thing to notice here is in Go, the function can return multiple values. So here, colon and arrow are both the return value from that function. And colon, it is the connector we need in the following part. And the arrow here means if any exceptions thrown in this function. So here I just charge the arrow variable and do some exception handle. And after that, I can use this connector to do what I want. And in the server part, kind of same thing. I use listener. I got the listener and the arrow, and just the arrow, and I can use the listener to listen, to receive some messages from my client. So this is how basically I build the connection between the client and server. So basically, it is same thing with the WCF in SMA. And I plan to use IO package for doing the file transfer in my project. And IO package provides some approach to do a file copy using some methods like copy n. So it basically will copy some bags from one folder to another folder. I like to say it is a file copy, it is not file transfer, I think, because I can only do it only use this method to do it in the same machine. I cannot do it remotely. But what I does right now, it is a file copy. You can see the code here. I just charge the size of that file and try to do a file copy from one folder to another folder. Yeah, and another thing is I plan to use path package provided by Go to do my directory synchronization. And like I said, I just before I want to do a file transfer, I just charge. If I need to do a directory synchronization, I just use some help function provided by path package to make sure the directory structure is same. And the package file paths implement utility routines for managing the different paths. And what's next? So right now, what I did is I did communication between client and servers. I did file transfer. I did directory management. So the next step, I plan to do. So one thing I plan to do is I want to design more and make sure my design looks better. Things like I want to create a message package, which will manage all the message in my system, so make my design looks clear. And some other stuff, I'm still thinking about some other stuff to add to my design. Another thing is I want to develop a version control in my server part, and in case of user want to check some older version. So I'm not doing something pretty complicated like a repository. I just want to do a version control. Because, for example, like the user wants to check the first version or the second version of some file, I can provide to them. So I won't do too complicated stuff like dependency or some stuff. Just keep different versions, old versions. And my ambitions, if I have enough time by the end of this semester, I plan to give a try to do the file synchronization between different machines. So right now, I'm pretty sure it is doable to do between different processes, use the technology as I mentioned, but I'm not quite sure I can do it between different machines, and I think I need to use some cloud stuff to do that. So yeah, I will give it a try. And the second thing is I want to create an ownership mechanism. So I mean, there are many clients here. I want to group them like a Dropbox. So the same group members can see the share folder of themselves. They don't have access to the other groups folder. So that's what I'm thinking about to put in my design. And my schedule here, by the April 12th, I plan to finish my design and did all the necessary prototypes for all the technologies I want to use. And by the April 19th, I plan to finish all the help packages, like I just mentioned, like message package, things like that, and connect them together with those prototypes. I want to connect them together, make sure it works between different processes. And after that, I want to do the version control, provide a version control mechanism, and by the end of April, I plan to do some stuff about my ambitions, like different machines I mentioned and ownership mechanism. And that's my end of presentation. Thank you. Any questions?
Good, you finished ahead of time. Fantastic. Good for you. Okay, guys, it's really important that we stick maximum of 30 minutes, okay? Because we're running out of time. You weren't here when I was talking about it, but we're going to have a hard time finishing by the end of the semester. Yeah, I've got. Do you have a display board? Then that's probably a problem. You sure you don't have a display port? Because display ports were Apple specific. No. Somebody loan you what you need? Oh, okay. Here it comes. You got it.
Our project is a grading website for data structure class, a lightweight online judge. Our presentation will be delivered in such an order. First, let me talk about our motivation. Our motivation comes from the fact that programming courses in our department have no specialized website for submitting and grading homework. Last year, Tammy and I both took CSE 674 data structure course. We find that the way we receive and submit our homework is quite inconvenient. We got our homework assignment as a CPP file, and a few comments were made as assignment description and requirements. So we believe there is a better way to do this. This is submit page in Blackboard. So there are some defects, we believe. And for students to submit our solutions, there is no syntax checking tools provided, no test tool is provided, and no discuss area is provided. And it really takes time for graders to process data for each solution. So think about this. If we have such a website, it would be very helpful. This website should be featured in for students. has an online compiling and testing tool, provide a standard test environment. So compatibility issues would not happen. Students get no chance to say code works with my computer perfectly. I don't know what happened with the grading system. And test tool should be provided in this website. And for course assignments, we believe sometimes additional documents are necessary for illustrate our solution. So the website should be featured in allow us to upload documents for our assignment. And for professors and graders, if they can manage students and manage assignments on the same website and design assignment and grading policies in a needed way. So we believe this website would be very helpful for both students and professors. So we conclude that what we actually need is an online judge website. There are many public online judge websites. The most famous ones are itcode.com, hackerrank.com, and UVA Online Judge. So there is another question: why don't we apply those existing public online judge websites to our programming courses? I think that's because the public online judge websites do not allow us to create customized problems, create customized judging policy. Like a professor who wants to give a little extra bonus for an assignment. So maybe some test cases may be given more points rather than compared to other test cases. And public online judge website doesn't allow us to do access control. Think about this: if a professor give us a problem that can be easily found, that there are always some top coders willing to help. So everyone, if we don't have access control, everyone can get full marks in a few minutes. So that is why we need it. So our goal is to build a private online judge website. Okay, here is a diagram for a typical online judge website. A typical online judge website consists of three major servers. The first one is web server, which hosts the web pages. And the second one is the core of the system, that is a judge server. And the second one is a database server. Okay. When the user signs up and logs in this website, he submits his code through the web server, and the web server transfers the code to the database server. And the problems created by the professors are also stored in the database server, and as well as the grading policies and test cases. And then the judge server fetch tasks from the database server, as well as the testing cases and the grading policies. And then the judge server compiles and judge if the program is right or not. And then the judge server write back to the database server and send the back results through the web page to the users. Okay, in this system, there are two kinds. This is a diagram for the data and message communication. So the message here refers to HTTP message. This system have a very, I think it's complex communication way. That is, the user sends HTTP messages to the web server, and the web server returns. And the web server should also communicate with the judge server. Judge server and the database server communicates with each other. The database server send the problems, the solutions, and everything else to the judge server, and the judge server send right back the results. Okay, this is a diagram for a typical online judge system. Our goal is to build a private, stable, and lightweight online judge website for programming courses. We borrowed some ideas from the typical online judge system. Tammy will present the technical part of it.
Given like the typical current solutions and the unmet needs, so we build up like our solutions. So like we focus on these user groups like professor, student, and grader, and developer. The professor here can like create classes, assign homework, quiz, challenges. The student here can like submit their solution, submit their homework, and the grader here can like check the content of the assignment like submitted by student. And the developer here can like maintenance of the system and can be like future for like add-on features. So our design here will be a little typical, a little bit like different from the like typical current solutions. So we have like four servers here, like web server, repository server, database server, and jar server. These three servers will not contact each other. They will only send message to web server here. So that's because the technology we use can like greatly reduce the workload of each server and like the complexity of the system design. Here, MongoDB provides like a NoSQL database, which really convenient for us because like we don't know like how many assignments in the courses like a professor will provide. So you can, when you create a collection for courses, for course description or course content, so professor can pen the assignment there. And then the Express framework for Node.js here is like act like HTTP server here to tackle with the request and give back the response. And to realize this logic is called like a routes here. Like if you like get request, I return one page. If you get a post request, I will pass the post body and do something for the response. And AngularJS. So AngularJS really is like powerful front end JavaScript library. You know, you can like write code on your front end at your front end page. So your front end page can like you can put your logic there. You can write a for loop there. You can even like do a math on the front page. So that make our design really unique. This is what I just talked about. So like for each server, every server will have its own MongoDB there because they do not contact with each other. They will have like same kind of have the same name of the collection. So they can be like fetched later for the web server to tackle with the different kind of requests. But the judge server here will be a little bit different. We will not apply like Node.js on the server side. We will use C and C++ there because Node.js cannot like compile the program programmatically. So we discuss a lot of time like how to correctly implement this kind of, how to use the compiler on the system, how to like for the task management really like directly. So we decided to use a C++ there. So let me talk more like details about the web server. It's really key feature in our system design. So the web server will deal with the client request. There are so many different client requests like login, sign up, like submit your assignment, like check your results. So the web server knows how to deal with that. And so if they know a request, like just a simple request, like if you sign in, the web server get your username and password, and you fetch data from like our database server there to compare whether it exists or whether it's right, and then return an organized web page and return it back to the client. So I will use some cases, like really classic cases, to talk about our system, how it works. Like professor here, if he wants to like create a classes and with the name sheet of the students, so the web server will get the name sheet, the course ID, and then we will let these three server to create a collection, NoSQL collection, like the name is like the course ID and all the student names on the name sheet. And meanwhile, on the repository, you will also do something like create a directory for the courses, and then you will create subdirectories for every student in that classes. If professor want to, the other case is like if the professor want to like assign a homework here, so the professor can like design, you will design like the content of the homework, like the description of the questions, and he will also like customize design the test case, the grading policies to the web server. The web server will know it, and then he will give the description of the homework to the standard DB, because there's already a course table there. Just append to it the content to the table for each student, and then you will give the test cases to the judge server for like to also for the the collection and append it to each student. So if like future like student you will submit the code there, the judge server will no need to ask, oh, where's the test case, where's the critical like criteria, so you can just run locally, and then you will also like create like subdirectory in each student, like this is assignment 1, this is assignment 2 folder, this is assignment 3 folder, and then student. So students here, when the students log in here, and the system knows he's a student, so he will ask his 3 servers, like he knows his student ID, in which classes, oh, like attending in class CSE 765, what data about this, and fetch all data to this web server here, and then organize the page. Like if there's like if the professor assign me like homework, so you will show the content, and you will show like if I finish like homework 1, homework 2, the result is also here, and get it back to the web server. And if I like already submitted the file, and the system file, oh, it's there, I find it. Also, you will give this information to web server and render it back to the user. And because we apply AngularJS here, so like the assignment, we know we already submitted before due date, and so like the AngularJS can like already submitted. It has like it submitted before due date. Whether it can be successfully built, how many test cases passed, and AngularJS here can calculate the score. Like if you pass all the test case, you rate 100. So AngularJS here, like our server will not calculate your grades. You only be calculated like at your desktop. That means they can much like reduce the workload of our 3 servers. And you know, when you submit a code, so this is the critical part. When you submit the code here, and the server knows who is he, who he like which class, and then the code will be copied to the repository under the specific path, and then you will also send a copy to judge server. We will let it do like compile it and then test it, because you know the test case is already been here, so you just compile it. Just like compile, if it compiles successful, just run it, compile the results with the test case.
I'll continue to talk about. I'll talk about the backend side, the judge server, which is the most important part. Okay, first, I'll define the judge task as a combination of compiling and testing. So in our system, the judge server is supposed to fetch and manage tasks, and support multiple languages. This can be done by invoking the existing compilers like GCC for C, G++ for C++, Mono for C#. And we have also this server is also featured in Logging, and it can apply multiple test cases in each test, and it can apply restrictions such as runtime and memory usage. This is basically for safety consideration, but it's also for performance consideration. Imagine that if a student submit a bad code, which could be malicious for the server, the entire server could crash down. By the way, this is also for performance consideration because each solution submitted by the student should be graded according to its performance. And for each test cases, an isolated environment should be applied. I'll talk about it later. Okay, as I said before, isolated environment is essential for each test task. That is for safety consideration. Here, isolated means both limited access to system calls and limited permission to the file system. Our mental model is to for the first isolated, that is isolated access to system calls. We plan to write a whitelist to the system calls, so the program would not be able to invoke all the system calls in the system call.h. And for the second isolated item, that is limited permission to the file system. As far as I know, the Linux system has already provided a function named the chroot. This is a facility that allows an isolated and process as well as its child process to a certain path. That process that process would not be able to visit any file outside that directory. But here is another problem. In order to implement this, the chroot function would not really work under a root server. So we have to create another user, that is a judge user, in the judge server. So basically, our judge server is run under a newly created account rather than the root account. So in this way, we believe our judge server could somehow get away from some malicious behaviors.
Can you do all that with just permissions on the judge server identity?
Just on the server, right?
So you're setting permissions, what this guy is allowed to do. He can't. He's blocked from any directory that isn't. And you can do that with permissions, with file permissions. I think you certainly can do it on Windows. I don't know about Linux. Might save you some work. It would be worth thinking about a little bit.
That is a good idea. For the first isolated item, that is for the first item. No matter what kind of user we're using, we have to create a whitelist for system calls.
Because if he's not root, he can't make system calls. Period. I think. Right. You might check it because that might be a really nice solution for you. I believe that if he's not root, he can't make system calls. I may be wrong, but
and like send some message out, like we'll do some remove some folder, invoke some system call like that. So really do
I think you have to be root to do those. But anyway, we'll take that offline. You take a look at it. It may save you some work. Maybe what I say isn't true. But
okay, and how can we apply restrictions for each program? There is a function called getRlimit in the Linux system. It allows us to get and set resource limits for each process. And when it comes to task management, our mental model is to use a blocking queue with the connection between the web server and the judge server. So so each task will be in the queue, and then the judge server will do it one by one. So in this way, we can also make the judge server to be scalable. That's because we can apply multiple judge servers like that. Each one run the process. This is a CSE many page I found in the. This is an example of system called like this. How we. Okay, and I'll talk a little about the data. The data stored in our system. As 10
You gotta
minutes.
be careful because we're running out of time.
Okay, we have 3 pages left.
Do them very quickly.
Okay. Okay. The following data are will be saved in the database. That is courses, users, assignment, and the judge result. And the following data will be saved in the repository server, student solution. That's because, as I said, documents sometimes are necessary. But unlike the problems in the programming context, as we find in the leetcode.com. Courses assignments are featured in, we know on leetcode.com, the solution is right or wrong. But this assignment is not the same story. Judging policies are more complex, as I previously said. Maybe a professor maybe set up extra bonus for some test cases. And late fees may apply. And sometimes the curved grades may apply. So we introduced so in order to better management the assignments, a typical programming assignment consists of the following things: description, restrictions, template, due date, sample input output, test cases, and sometimes sample solutions. We introduced XML technology.
We have time for this. You have 5 minutes to finish. Period. Okay.
Okay, we introduced XML technology to help professors better manage the assignments. So if we don't use this kind of technology, professors have to use a text editor on the website and type everything one by one. So this is a problem title, and this is.
Let's not do this.
Yeah.
Let's go to the next slide.
Okay. We're always done. This is our timeline. Now we have already built a sample website. Now it's March, so we believe we are into the timeline. Okay.
Forget the code. Forget the code.
No, he's starting
Go
the
back to that slide. Go back to that
website.
slide.
He's starting the website.
Starting our website and it's a little demo of
Can
our
we look at
website.
that slide? We're not going to have time to run your website.
Wrong.
Okay. I just want to see this slide.
No, just a little demo, just really fast, 1 minute.
What you're doing are the probes that you're supposed to be doing in the probes.
Just
Yeah, let's not do this, please, okay? This is a probe. That comes in your next presentation.
Okay.
We'd be happy to listen to it in the next presentation. Just go to your closing slides.
It's a website.
already.
Can you go to your closing slides, please?
Yes, please.
So blow up the time, no, blow up the time, let me see the timeline. Make it, can you make it bigger, that slide? I want, play that, okay. So, are you up to date on this schedule? So you've built up the web server, the simple judge server?
Simple judge
Is
server.
that
No,
done?
no, just the
No.
simple web server.
Okay, so you're a little behind schedule now?
Yeah.
Okay, so, the project certainly is a reasonable project, but you got a lot of parts.
Yes.
I'm worried about you getting killed with all the parts.
So what we did, what we want to do is a simple, lightweight. We reduce all the connections between each server and data. And that would
One
be
of the
easy.
most interesting things is the judge server,
Yes.
and get that going and show us how that works. And, you know, we'll believe that a lot of the other stuff can work if you have that. So I would suggest you focus a lot on that. And then if you have time, add some more of the other things. Good, thank you, guys. For all the presenters to come, you know, the technology presentation, my mental model is no code. That all comes with the probes. Okay, a lot of us have been doing code, and I won't say you're wrong if you do it, but you know, we're really limited on time is the problem. Thanks for being willing to go ahead, Rick. Yeah.
Display part.
So, yeah. So you need this?
Yeah.
That's a display port? Oh, yeah, you gotta, actually, there's one right in the drawer
Oh, is there?
that works for this. So, in that case, so I don't forget it, let's use the one in the drawer. Okay. So Fred was supposed to go on Tuesday, and he kindly agreed to go a day ahead of time, so. We'll give Fred an extra round of applause when he sits down, because I'm ahead of time.
All right, hi, I'm Fred Liederbach, and so I'm building a facial recognition system prototype. Unfortunately, I didn't realize this before, but it's quite similar to, I think, 4 other projects we've seen now, or this is the 4th similar project. So I'll try and skip over some of the stuff that we've seen in other presentations. So my goal is to build a simple, easily expandable facial recognition system that consists of a Raspberry Pi running some facial recognition software, a web server to aggregate information from, well, for this system, just one Raspberry Pi, but in the future, potentially more than one, and a web application for users to view information. Okay, so the model here, as I said, is I've got one Raspberry Pi for this, but in the future, you could expand it to an arbitrary number of nodes to collect data.
So is your model, as you accrue more Raspberry Pis, are you splitting up the images?
No. So each Raspberry Pi has a camera, and they continuously look at that camera and say, okay, who am I seeing?
So you're taking what would have been a whole series of and scaling it out.
Yeah, so you can just have different locations you're looking at. So, you know, some different areas where I thought this might be applicable is, you know, a customer or a company could have their employees use it as a check-in system, check-out system. Companies can track customers, which is kind of creepy, but probably already happening. And for me, I thought it'd be interesting, a home security system. You know, so I don't really care about looking at my phone to unlock it, but it'd be nice to look at my front door to unlock it. So this is kind of my project structure. I've got a Raspberry Pi, and I think we saw on Tuesday running OpenCV computer vision library with the webcam, and then talking to a server through a socket, which has a database, and then a client web app that you can view the information. So we'll look at some of the components here. So starting with the Raspberry Pi, I've got Raspberry Pi 2B that I had in my closet, so hopefully I don't have to get a new one. And a basic webcam, and then the software I'll be using is the OpenCV library, which is an open source computer vision library that has all kinds of stuff, but I'll be using the facial detection and recognition. And then OpenCV has interfaces with, I think, C++, Java, Python, and MATLAB. But there's a nice collaboration out there that is creating some interfaces with, so that you can use it through JavaScript. So the rest of my project's in JavaScript, so I think I'm planning on using that. And then, so this is kind of what's going on the Raspberry Pi. Is you're continuously looking at images from the webcam, and then the computer vision library is checking, does it recognize a face using image detection? Does it detect a face? And if it does, then it goes into check I'll talk about this next, but you have to train the face recognizer, and so it goes in and checks, okay, do I have this face in my system? Do I recognize this face? And if you do recognize the face, then you say, okay, I've recognized this face, and you send off a message to the server to say, I've seen this face and I know who it is. Okay.
The system probably would want to know if you haven't seen that face too.
Your
front door.
Yeah. Yeah. Yeah, I suppose so.
Yeah.
Yeah. So yeah. So I'm going to talk a little bit about the face detection. I'm from the math department, so I won't go into any detail, but this stuff is interesting to me. So the first part is face detection, and this Viola Jones object detection framework, I guess, is kind of the de facto object detection algorithm. And so it can be used for any object, but I think it has been kind of fine-tuned for faces. And so this is all it takes to run the algorithm. And this cv.face cascade is a set of classifiers that are provided by OpenCV just to specifically recognize faces. And so you'll pull up an image, you'll check this image to see if it recognizes any faces, and then the function comes back with X and Y coordinates of any faces along with the width. So you can identify where those faces are and pull out that to do the recognition to see if you recognize the face. Okay, so here's, you have to train the face recognizer. So we've detected the faces, now you need to tell the system what faces you want to be able to recognize. So basically you come up with, you need to have multiple images of the faces you want to be able to recognize, and then you feed these images into the system, and it builds, as we'll talk about next, it builds an image of what it expects to see.
So the first three are different algorithms for doing this construction?
Yeah, these are the three algorithms for recognition that I'll talk about those next. So you just feed in multiple images of the same person, and you give them a label saying what person it is. All right, so these are the three algorithms that OpenCV has. The first one is eigenfaces, and it uses principal component analysis, which basically takes an image, which is a high-dimensional object, and it transforms it into a lower dimensional object so that it's easier to compare. And so the idea is that the image, most of the image is correlated. You're going to have light areas and dark areas close to each other. So it reduces the amount of data while maintaining all the variance, so you get the most important parts. Fisher Faces does a similar thing, but instead of just maximizing the variance for the individual face, for the individual person, it looks at all the different faces you have and maximizes the variance given that you want the different faces, in the space of faces, you want the different faces to be far apart from each other. So that it's easy to detect where the difference is between different faces. Now, the issue with these two, from what I understand, is that it's not like the typical image you have of face detection is that the computer's pinpointing where's your eye, where's your nose, and saying what's the distance between that. This doesn't have any sort of feature detection. It just takes the image as pixels and treats it as a matrix. And so different light can affect this. It doesn't take into account any features. So this third This third algorithm is a little bit more designed to account for features, and it does that by looking at local bits, local parts of the image. And so I haven't really looked into this too much, but it takes little local areas of the image, and it computes. You say, okay, for the center one, am I higher or lower than each of the surrounding numbers? And then by that way, we can compute for this. We can compute an 8-bit.
Sounds like they're doing something akin to edge detection.
Yeah, I think similar. And so you get kind of a rough image localized. So those are the brief overview of the three that the OpenCV offers. And so here's in JavaScript. Here's running the predictions. We've trained the recognizer for a few faces. And so then you run the prediction, and then this is, as far as my understanding, the equivalent of a lambda in JavaScript, and it's just printing out what face it recognized and the confidence it recognized it with.
What's the scale for the confidence?
I'm not sure.
1,200.
I'm not sure about that.
Okay.
Yeah.
That's okay.
Yeah, I'm not.
Yeah.
I haven't really dug into that yet, but so here's comparing eigenfaces and Fisher faces. So they both, hit 90% accuracy with about 5 training images or so. So pretty good on those.
Is there some reason to believe that this on a Raspberry Pi, my mental model is that facial recognition is a very intense, CPU intense kind of activity?
Yeah, it's been done. There's lots of other people have done it. So yeah, that was enough for me to believe it's done. I'm sure.
I think the earlier group had said the same thing, but
yeah, there's plenty of people who have done similar things.
It just really blows me away that the Raspberry Pi could do that.
Yeah. Okay, so the web server is going to have a queue for bringing in all of the faces that have been recognized, and then pull the images off the queue and put it into a database, and then support queries from the user to view different information. So I'm going to use Node for the server and a MongoDB database, which we've heard about plenty, and then I think I'm going to use the socket.io as it's an event-based bidirectional communication layer for real-time web applications. From what I've looked into it doesn't actually always use WebSockets. It kind of uses what's available, but it seems nice. It pushes kind of all the nitty-gritty down below the surface, and so I'll do it. I've got a
So whatever your platform supports, it
Yeah.
tends to use?
Yeah, any platform. Yeah, and I think it also you can use C++ and other languages, but it's simple for Java to Java. So here, this is an example of establishing a communication and sending some data. So on the server, we check is the connection on, and then if there's a connection, we listen for data coming through, and then we just print out what the information passed through. And then here on the client is an example of sending some data through. So that's my plan for the Raspberry Pi to server communication. And then finally, the web app for viewing the information. So I want the user to be able to run some queries on the information in the database. So they select they want to see when this person has been where and at what time. You should be able to select some information and see if any of those, if Bob came to this house between 5 and 9 p.m. And I want to make the website responsive. So that's kind of my basic layout, and these are some of them are more ambitious than others. Some of them aren't that ambitious at all. So maybe I'll accomplish some of these if I have enough time. So the first one is add login, so you can have different users who maybe have different access to different cameras. And then the second one is I'll start out by just manually training the recognizer on the Raspberry Pi, but I would eventually like to add the capability to just train the recognizer from the web app, feed the images in from there. And if I have individual users, it would be nice to be able to have them set conditions for if somebody shows up on this camera, they can get a notification. And finally, you potentially add, if you wanted to, from the website, see a live feed of any of the cameras. Be interesting. And then more ambitious goals would be to build an Android app or connect a lock to the Raspberry Pi so when it sees a face, it can unlock or lock the door.
Hopefully it doesn't make mistakes.
Yeah, well, that I don't think I'd want to do this on my house because I think that it's not like the iPhone where you could hold up a picture and it'd let you in. So this is a schedule of sorts. So we've got 6 weeks left. So I've been doing some probes and currently working on the communication between the Raspberry Pi and the server. So next week I want to set up the database and build a simple website just to test the connection of getting data from the database. And then the next week, work with the Raspberry Pi, get the face detection and recognition, test that. The next week, send and store data from the Raspberry Pi and test that communication. And then the final website, make the website more robust, work on more ambitious goals, and then polish and debug. And that's the end.
Terrific. Any questions of Brent? Okay, so that's it for today. Stick around for a couple of minutes. Let me chat with you after class. I want to apologize for pulling you off, but so on Tuesday we have Eric and Yaha Zhang and Bimo Zhang and the root. So we're going to have a real hard time getting done. I'm sure we'll go a little over. Now, that was why I was trying to keep you guys contained, because to get as much in today as we could, so that because Tuesday we're definitely going to go over. It may be just you and me presenting. I'll try to con some people to stick around so you have a bigger audience than just me. But that's the game plan. And then on Thursday, we're going to start the probing presentations. If you came in late, go to the syllabus and click on the probing presentation, that lecture number for the probing, and that'll take you to the probing presentation. I've put some comments about an ideal presentation. What I think would be a good thing with the probing presentation. Okay, and my model is, once we do the probing presentations, a single member team has 45 minutes, a 2-member team has an hour, and you start losing points if you go over those. A point a minute if you go over those. Okay, so just as a forcing function to keep everybody on time. When you work professionally, it's really important to stick to your time. Whatever time is assigned to you, it's really important to stick to that. If you don't, everybody gets angry at you. They're saying, you think you're more important than all the rest of us because you're dominating the time, didn't give us a chance to speak. So not good for you or your career to do that.
Are 3 probes required? And have 3 different things? Or what if you have one bigger thing you wanted to show and then a smaller?
Oh, that's fine, yeah, that's fine. So I listed 3 probes, but if you want to do one big probe and one little probe, that's fine. If you want to do one huge probe and no other probes, that's fine. Okay. Just pick it to be as illuminating as you can, right? And, you know, I'm asking you in that outline, I just labeled the slides, slide 1, slide 2. And the first 4, just a quick review of your first 4 slides, and you just zip through them, just bam, 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 bam. And then 10 minutes of probe is my mental model. So you're 30 minutes for probes in total. And so clearly you're not going to demonstrate all the code in your application probably, but that's stuff that's really interesting. I liked, you know, the presentations were, the only issue I had with your presentation is you went over. And I liked the presentation today. I thought you guys did a good job. So, you know, Fred, pat yourself on the back. Janan, pat yourself on the back. You guys pat yourself on the back with the attending, and you don't pat yourself on the back with the reservation that you went over. Okay. So, my game plan is this weekend to finish filling out grade sheets for everybody, so you'll know the grades that I've assigned you for the technology presentations, so that, you know, I want you to keep, you know what your status is, you know where you are. And the deadline for project 1 is April 3rd. Okay, any questions before we break?
Do we already have the ordering for the, or is it the same for the presentation?
Yeah, it's all, so I'll take a minute for anybody who wants to stick around. If anybody who doesn't, they can leave, but. Still in. One key doesn't work. Where's the mouse? So this is, by the way, before I get to what you asked me about, this is, you know, what I wrote down is what I think is an ideal presentation for the probes. Oh, thank you. Let's go to PC. So, you know, it's here, you can look at it. Now, let's go to look at the schedule. So, those things you can get, you know, I did the same thing for the technology presentations, you know, down here. I just did this afternoon, so, you know, you didn't miss anything, you know, but this is what I think an ideal technology presentation would be. No need for code. You know, you can use it if you have time, but no need to. Now for the schedule, everything is assigned right through the final project. So probing, here's the probe schedule, and here's the final presentation schedule. So all the final presentations are going to be on the 3rd and 4th of May. That's in the reading period, so I'm not supposed to do that, but nobody should have an exam scheduled that way, that day. And what I want is, I'm not going to require everybody to be at both days, but I would like to see everybody be at one full day doing that, so that the speakers have an audience. So if you're speaking, I'd like to have you there the whole day, so that people hear you speak and you hear them speak. So, and if we really keep to the schedule, we're really, you know, focused on managing that schedule, then we'll make it on time. If we don't focus on managing that schedule, we're going to flow over and we're going to have big trouble in River City. Okay, so. How yo? So Cheng Wang would like to talk with you.
Yeah.
Because he's interested in your, have you already talked?
Yeah.
He's interested in your project.
Okay.
Okay. Any questions before we break? Fantastic. We're broken, and we actually got out a couple minutes early, so. So, I was kind of, I felt bad about doing that. I just want to, it wasn't you, it was just I want to make sure that we got that one presentation in so that we have a chance of finishing on time on Tuesday.
So next Tuesday I have to give a presentation, right? Do I still need to do up some tutorials? Do I have to teach?
So here's what I think, here's what I think an ideal presentation is. So,
I don't think we have enough time.
just hang on a minute. So, here's the technology presentation. So let's go to that page. So, you don't need any code, but you want to talk about the technologies that you're using.
Yeah, actually, I have already prepared the code for React, but I don't think we have enough time.
We don't have time for that, I don't
Yeah.
think. But you can talk about React. And here, my model is that you're not, maybe you've got 4 different technologies you're using. You're just doing 3 slides on one of those. Pick the one you're most comfortable with and do 3 slides.
So I don't have to go through VS Code. I don't have to.
No, just pick one that you think is interesting. VS Code would be an interesting one to do, but it doesn't have to be that. It's whatever you choose.
Okay, because the code is long, so if I put into the slide, you cannot see it.
Yeah.
So I mean, I can pull up VS Code.
Yeah. So just pick one that's easy to present. All right.
And my timeline and milestone is really long because I put everything because I put it on my calendar and now I'm on the plan. I'm not behind the schedule. I get most of the things done.
Okay.
Yeah.
Well, that's fine.
So-
Just show us what you're trying to do.
I don't have to put everything there, right? Just
No.
I mean because my schedule is so complicated now.
Yeah.
I simply Google Calendar.
I would leave it the way it is, and you don't have to put every single thing that you say I might want to. I'll do if I can. You had a whole bunch of stuff on your agenda. So I don't have an issue with that.
Actually, I'm almost done with the node part.
Oh, good.
Now I'm working on abstract.
Yeah.
Actually, my
Apologize for otherwise I would
That's okay. Yeah. Well, there was things switching around the last minute, so don't worry about it.
I go it was all about
the function is, the search is.
What I'd like is your presentation to take half an hour or a little bit less.
I do have the parts in there.
Yeah, I want you to do justice to your project. I don't want you to, slam through your project. I want you to do justice to it. But we just can't go.
But we don't
get
have
along
to
with
include
it.
everything.
No, absolutely not. Absolutely not.
Because my confusion is we have to explain every single part. That's what I'm using.
So what you want to do, you may not even know, all the details about all the critical parts. And so in this technology, this is a forecast. You're saying, I know I need these technologies. And this one is important to me, so I looked at it, and here's how this technology works.
I mean, they're all important, but without any of them, this technology would work.
Yeah.
Like, for instance, my fabric part, based on this.
I think that's a really interesting, so if you just pick that, you say, Christina talked a little bit about some of the communication, so I'm not going to cover that. But the fabric part is really interesting. That's the thing that interests me most, so let's talk about it.
But the communication part is what makes the fabric interesting.
Just a group of
Well, you pick however you want, but you're not gonna have time to cover everything, because your plan was pretty ambitious.
It was pretty
You know,
exciting.
what I care about is that you do a good job and you end it half-assed.
现在的问题就是在于
Mental models pretty much just want to present the big
按理
picture.
说这边能够刷新。
Present the big picture and some slice that's interesting, okay?
我是怎么来想这个问题的？
Everybody done asking any questions about this?
I have a question. Well, not about that, but, for the last, or second to last requirement for project one, with this fit method, so does this
其实
mean
那个
that
我觉得那个
if
功能
there
没有必
is
要，没有必要。
data in the, for example, block queue, and you retrieve that data, it'll return
因为
true?
那个东西是放在它的。
I'm perfectly, so
我知道，但是你每次
this success code is that it found the text.
我是
I hope I said it, maybe I didn't write this totally correctly. So,
如果你
send me an email about it and I will look at that, but let me tell you what my intent is. My intent is
针对
that
这个东西，我
the two components have to talk to each other.
但是它这个假如
One way, it doesn't need to be two way. And I don't care whether you use push model, this guy pushes his data to that guy, whether you use, this guy pulls it, two ways.
但是只有它需要
And the model is that what you're returning true is that you found file by file by file, you found the texture you didn't find the text.
不会不行，不会读，就不会读那个。
Like, oh, like per file, so like
Yeah.
one file is either true or false.
它不会识别这种
Found the text. So you're gonna return, what you're returning to the client is a list of the file name,
它不会写，
what you're returning to the client is just a list of the file names where it's true. But this other
所以
component,
说我觉得
I wrote it that way so that, because there's a couple of other ways, you could get a little more information out. If he generated that, and so.
我的 press 不行，但是我现在就是因为三个，
So if you wanted to build another component that did this analysis or something like that, when it returned true,
我
you
之
could
前
do
做了一个就
Okay.
像这样的一些，
But per individual file.
Yeah.
生成一个然后卖。
Thank you.
就因为不然你每次都要复制一下， 对， 然后它我
Now at least.
因为我自己我是
Until I get more confused at
我
a
是有一个
later
另外的一个小程序帮我自己把这个东西加上去，但是另外一个我就是写一个
Everybody did
我之
it.
前就是
I was like, wow, our projects are.
其实这个很简单，就是我其实看特别的，主要是我不建议，我是觉得你这样会把你的 UI 搞得特别的复杂。你针对不同的 blog， 它
And my computer is like
每
almost
个的
dead.
就是图片怎么处理。图片我不知道是看我的，
I would,
先选
No, I don't like to carry
okay,
it.
do what you wanna do, but I would spend less time talking about Dr. Chen's.
Well, usually I'm carrying around like my workout
And more
gear.
on yours.
So that I go to practice.
Mostly characterize it. We don't need to know.
I just usually have a lot of stuff on me. Right now I don't.
Yeah, as long as
这个是你要
you,
去看这些 API。
you've got 30 minutes total. And I definitely wouldn't want to see you spend more
到
than
它上层的那个 link。 直接拿回来就看它返回的是什么。
Yeah.
不，返回的不是链接，但是你要去看我自己来找个链接，每个 API 都是不一样的，所以你需要做一个这个东西。之前是我给你出图片，
Yeah.
Tuesday?
做完
Are you gonna go over now?
So, where are you gonna be first?
可以，你那样做可以，你要做。
No, you're gonna be second, because I'm very
那样做 因为我之前没有
You'll be first.
你有 editor 可以直接展，我是相当于说我有一个现成的，我有一个哦，我得知道，因为它可能不是从我这里，所以我得扫一遍。我觉得这样，如果有 editor 这样，其实两种设计各有各的好处。我这个其实我这个
So you mean the probing
看着
presentation?
很多台我的造
Yeah,
它
so
的
here,
把它的功能一个一个实现出来。除了另外就是说，我觉得它这个设计主要是你说的那种，就是 parse 一遍，它有可能出现一种问题，就是
So
parse 的
you're
那个我们有的是
on
网页链接，
pre-April.
有的是
You
就
say
是
you've
那
got
个
some.
就是
You
本
can
地的
definitely switch, just find someone to switch with you. And,
对，但是就比较麻烦，你知道吗？本地你可以直接上边，
what I will
但是
do
如果
is
是网
I
页的话，
won't
你要
change 你
判
your
断你
place
上
on
传
this
的那
chart,
个
but
算
I'll
法它
change
是否
today,
支持
I'll
这
change
多少
their day.
或者是说你要把网页链接 download 下来， 变成本地文件。
I don't wanna, I'm really busy and I don't wanna have to go trying to do a whole negotiation.
我觉得自己对，如果是就是不是自己，这就是一个问题啊。所以说就仁者见仁，智者见智。都挺好的。你看那个我的那个 demo 里面是想把那个最简单的那个 Windows 放进去。主要那个 Windows 你其实
So what happens,
加入
buying
用的 Windows 当中有两个 package，可以选择一个看的，一个是
what you're talking about the bind function in the socket API. Yeah. What that does is that tells the listener to bind to that network card.
加进去，然后配置一下就行，包括这些配色。